Audio check. Test 1, 2, 3. Okay, audio looks good. This is the time when I switch between projects and it ain't pretty. So let us kill some buffers. Because yes, we are changing to our compiler work today. Today's Friday, compiler day. So I'm going to kill all the buffers from the game development we do. We'll pop open our compiler stuff. I think this might have been another week of making a lot of changes that won't result in code growth, which is sometimes very good. Man, I had a lot of buffers open, didn't I? Sheesh. We're getting there. Slowly, slowly. Okay, so in theory, we should only have like 2 buffers open. Perfect. Scratch buffer and that one. So let's bring up PVE documentation to do and journal. Where did we even leave off last week? Like, I know we were. So we had pattern to NFA, which we were working with separate from our configuration. Then we did NFA to DFA, and that was working. We were in the process of compiling each rule's NFA into a single NFA. And we ran into a bug. Oh yeah. And we committed with it broken. I knew it were broken, and now I'm remembering what it's about. This is the problem when you only code a project for once a week. You have a lot of time to forget. Oh, goodness. Feeling a little slow today, but that's okay. So that's step number 1. We're going to finish this. We are changing the way we do our code. We need to keep track of any stream statistics here yet. So I wrote a script that would scrub through my Git repo and keep track of lines of code, churn, and the hours that I've worked on the project. So we can now compute all of the statistics of interest anytime we want. So we don't actually have to store it in the journal anymore. So let's go ahead and clean that up. Let's reduce our journal overhead here. We don't need stream stats anymore. We're only doing 1 day per week, so this degree of statistics is maybe not as helpful. So today, 23rd. Oh my goodness. Tasks and notes. Starting with the strange bug we had at the end of last week. If we get through this bug, combining each individual NFA into a single monstrous NFA shouldn't be too bad. Then we've already got most of the code for that somewhere. We can copy paste or uncomment it as the case may be. And then we will compile that to a single gigantic DFA, which is also fine. And if we get through those two things, then we can start generating code from our Tokenizer generator. And that is, we won't be building anything functional yet, but we're going to certainly build up all of the framework of code that we need to run. So I think that's the general plan. So let's look at our to-do list. Okay, we need a text buffer, we need a character reference, a string reference, we need a compiler context. We will want a namespace so that those things don't collide. Some file paths, that would be nice. Yeah, those are make me sad. Pardon me. We're really keeping very good track of escaped characters, and there's some output oddities, even if the rest of it is correct. Okay. Oh, and then obviously Tokenizer has DFA state table. This one we're gonna have multiple builds of. This is actually a multi-stage thing to, let's see here. This asterisk, several different methods for comparison, for performance comparison. Okay. Fact. I was avoiding using Git to version control the AI trash, but it's getting out of hand, and now I need to. Yep, that's how it goes. I know it's good practice to version control everything, but this was kind of a joke at the start. Oh, yes, I did sneeze. Thank you. Thank you. Yeah, I find Git just gives me a log. It lets me roll back anytime I want. It's just good habit. And honestly, if you're the only dev on it, it's literally just commit at the end of the day, and there's nothing else. It's really not a huge burden. It's when you start working with other people, then things get crazy, I think. I think Git starts to become both a tool of safety and sanity, as well as a big pain in the rear. Dravest, good afternoon. Life today is good. It's Friday. Well, I'm getting steaks for dinner tonight, so that's good. Got some T-bones I'm going to grill up. Always good when you have steaks to look forward to. And it's compiler day. I always like compiler day. And how are you gentlemen doing, Pat and Dravest? I really do apologize for slaughtering your name, but I'm not Swedish, so closest I've ever come is I've eaten Swedish fish, but that's like a candy. It's not even a real fish. So, biscuits and gravy. Ooh, I like biscuits and gravy. Biscuits and gravy are delicious. You doing a sausage gravy, or you got something else cooking up? Sounds really nice. I'm good as well. Thanks. No worries about my name. Okay, I'll just keep slaughtering it, and as long as you're not offended, I'll keep going. Sausage. Yep. Classic. Yes, excellent. Okay, so I think we need to figure out what this bug is. So VB tokenizer definition, where we basically say, here are the rules for how you tokenize. We added a vector to the header. And that causes us to crash. That's where we're going to start looking. Let's get us a shell up. Let's open up VB tokenizer definition. Here's that vector we were talking about. Okay. Now, I'm already a little sad that we're using a vector here, but this code is not like our game code. This does not run once a frame, every frame for 2,000 frames per second. So for me to use STD containers here, I'm not as worried about it. But at the point that we have all the rules, we can it's fine. We can do this as a vector, it's fine. But this stuff all should compile, clean, debug, build. Names can be hard, no problem. Okay, great. And while that's running, oh, it's done. I need my gum. If I don't chew gum, I'll eat junk food and get fat again, or get fatter again. So. Struggling here. I can't get gum out of a package. Doesn't bode well. There we go. Got some gum ready to go. What were we even doing? We were probably doing source builds, debug, VB, whatever. It should print help. Need is a dash P. And it's like VB project. Oh, I don't have a file like that. Is that not? Tests.vbp. Okay. So where we left off, apparently it tries to open a file that doesn't exist. That shouldn't cause us to die. Let's look at our file. Text buffer. Read file. Right now, I believe we are using file f open, so we're doing this one. No. F open, this one. In file equals that. Could not open file. That should log a nice error, and it's not. So if I give it a bogus file, it just crashes. And I don't think we can get a backtrace out of that. inside VB project parse at line 27. String copy. Do I need to test for file existence before I try to open it? I don't think I ever have. You just return. An old file handle. This is strange already. Doggone it. All right, text buffer. I have some code lying around in sleuth application. Let's see. Do that. Then when we get our file name, we get our struct. Okay. File text buffer. Not find file. Guess we do that. All right, let's try that. We'll test for. Yeah, now we got that lovely warning. Run it. With a non-existent file, we're still getting a seg fault. What? There is no vb.vb project. Oh boy. Alright, something strange is happening here. Oh, it did say could not find file. That just continues. Okay, so that means we're being stupid. If text buffer dot size is less than or equal to 0, greater than 0. There we go. That should fix it. Instead of passing junk. That should help some. Project file could not find. Okay, so that's fixed at least. Test. Now we're back to debugging the bug we thought about. We were going to test. Adding a rule. Adding a rule. It is making copies of these rules, which I do not like. It's called twice. It's called again. Oh. Definition not. Not parse token. I really look forward to replacing this with code that we've generated. 1, 2, 3, count equals 0, and if input if count equals 3, do things. Found modulus D things. We're going to have to look at our tokenizer definition file real quick. Only found one things. Okay. Okay, so we have our test Fay, no, Billy, test Fay tokenizer. Two, three. Okay, if count is greater than or equal to 1. Name. Count is greater than 2. Then we want the actions. And if it's 3, regx, which we should never see, so that's fine. Already got TokenID. Let's look at our thing here. Search for any white space surrounding a thing. White space surrounding a thing, white space surrounding a thing. All right, let's simplify. So we're going to do scanf text plus offset. Any amount of white space followed by a thing, followed by a thing, followed by a thing. Number of things we read. Into name, actions, regex, and size. Count. Count equals 0, we probably got nothing. Count equals 3, we were happy. Otherwise, we could not parse the token. Let's see if that simplification just makes life better for us. Only found a 19 out of 3 things. Well, that is fascinating. Here, scanf return the number of items of the argument list successfully filled, and then oh yeah, that's so we need an int for size. Oh, size and offset. Get size set plus equals size. This is count. Number of things read, and this doesn't count. Read into name, actions, regex. How many bytes did we read? Moving our offset. If count is 0, we're done. Count is 3. If it's not, I can find them. Let's take a look. Only found -1 out of 3 things. -1? I didn't know that was an option. The return on success, the function returns the number of items in the argument list successfully filled. This count can match the expected number of items to be or be less or even 0. In the case of an input failure, before any data could be successfully interpreted, end of file is returned. I did not know this could return a negative. Stack Overflow never lets me down, right? Rewind function. What? Well, Just do that. I didn't know it could go negative. It doesn't seem to have a special meaning. Okay, so we're no longer getting parse errors there. 3 calls to a copy constructor, which I would like to remove if I can. Seems unnecessary. Then come over here to VB Tokenizer definition.h. Put in this again. Do a full clean debug, just because we can. Let's see if it works. Nope, straight up dead. I'm not even accessing that. Like, it's just a space in memory. Therefore, we should run this in debugger. Someday I will actually learn how to use GDB well. Let's see where the backtrace is, if we get one. Okay. GDB run stack dump with executable. Think is that all I do? Okay, let's do this. Tell it about the executable, and then we tell it vb.exe stack backtrace is not a core dump. Unbelievable. It's not a core dump. It's a stack dump. Blah, blah, blah. GDB. It's not a core file. It's a... People on the internet. It's a core dump. That is... I asked about a stack dump. How in Google can I search for a stack dump and get core dump? Unbelievable. Okay, so that's useless. Therefore, we have to do this the hard way. We are going to start with printf debugging. Project file. I'd like to remove these. Let's prefix them with something useful. File read. As data. Project object. I rhymed. Project object exists. Project object parsed. It'll never get that far. Old printf debugging. My old standby, my faithful friend. Oops. -p vb dot test dot vb project. The project object exists. We did not parse, therefore we're going to we probably make a few changes to push. So this is why I use my own logger. With push pop and top, I get hierarchical structure in my logging. Dankly tuned. Greetings, how goes the compiler hacking today? Well, we're trying to find the bug we left off with last week. If I add a member to a class called vector, I get a stack dump. If I remove that from the header, I don't get a stack dump. It doesn't matter if anything accesses it or not. So we looked at the stack dump. Actually, here, let's do that. Let's look at the stack dump. I've already done this last week, I guess. And frankly, it's not the most helpful. And GDB does not recognize this as a core dump, so I can't actually get backtrace information out of this. Anything more would be me mapping actual functions to function locations in an object file, which may be, I don't know, conf or elf. On Linux, it's elf. I think in Windows, it's conf, but I'm using like MingW or Sigwin, so I don't know what the object file format is. So, and I'm not doing that. So we're just back to printf debugging. That's where we're at. If we can get through this thing, I think we can blaze through a pretty good checklist of things to do today. Anyway, so I have these special logging class that lets me push things on and pop them off and then log it at a certain depth so I can see hierarchical information. So when I go to project.cpp parse, it already has track of how deep I am. So I can do a push and say project.parse. And this one is, we just want to know where it crashes. So top copy text. First name, first encoding, first token definition file. Otherwise, we are happy, and we can look up a parser definition file, which we do not have yet. Interesting, reminds me of my own debugging adventures in CFFI from Lisp, where you get the very informative unhandled memory error. Yeah, and you get that from Lisp, and you're just like, I don't know. It was even more fun when the bug was seemingly non-deterministic, or so I thought. Yes, so fun. So Lisp didn't give you memory. What was the actual problem then? Now I'm curious. I don't think I've ever run into unhandled memory error from Lisp, because it just makes things as you ask for them. It might be nil, but it does make stuff. Unhandled memory error. I guess you had a pre-allocated buffer that you deleted and then were accessing afterwards? Or, I don't know. That seems odd. It sounds strange to me. Okay, if result name copy token definition file name first definition file name copy. Oh, this is probably where we're blowing up here. So we want more logging here. Ready to copy to read token definition file. Token definition file read. Token definition file parse. That should give us a good idea where our crash is. The actual problem was me not understanding threading. Oh yes. Okay. Threading in OpenGL. Basically, I was attempting to call a GL command from another thread, when you can only, of course, issue GL commands from the main thread with a context. Yes. Okay. Okay, that makes sense. And in Lisp, because of the CFFI, my program would just crash without any good info on why. Yep, that makes sense. Yeah, anytime you start working threads, you get error messages, and they're not always very helpful. Well, I didn't get very far at all. Didn't do a build. Unless... Oh, everything should be logged. And this is as far as we got. uvproject.parse. Literally this far. So the clear function is my problem. What if we do that? I do wish my compiler or the debugger would do something more useful than stack dump, but okay. Project.clear pop token definition cleared. Deleted strings. Set default values. It's dying before clear is called. It wants semicolons for some reason. It wants more semicolons. You never have enough semicolons. Just put in an extra semicolon. Did I really just copy paste over and over again? There we go. Should short circuit this. How is the Lisp OpenGL fun? Token definition did get cleared. Okay. So that leads me to a notion. What if my parser definition file name is not null? It's a sad name, sad idea. But if that was the problem this whole time, I'm going to be a little bit sad and mad at myself, and more mad at GDB and my compiler. Well, GDB anyways, for not letting me know what the problem is. There, problem done. Issue solved. Oh my gosh. That was the problem. So now we have to unwrap all of our logging. Oops. That is an error. That one can stay, but this one can go on gone. This is the whole point of a debugger. I should get a backtrace when it tries to delete something that's not supposed to be deleted. But no, it gives me a stack dump with no useful information in it instead. That log is fine. Okay, VV Tokenizer definition. Don't care about that so much. That's an error. That is not an issue. Therefore, I think we can just do that. And that. What happened in clear? Rules clear. Tokens. Okay. Which I guess means we can just call clear here. Okay. Then our main function had a bunch of long statements in it that we no longer need. Oops. All right. There, easy bug. You just have to put enough print statements in. That's the solution to everything. It's good because now I can recompile shaders, VAOs, textures, and so on while the program is running. Yeah, that was one of the nice things about Lisp, although that also sometimes makes debugging harder because it does fail in odd ways when it's... Yeah. Right, shaders are very fast-paced. So this is GLSL. Cool. See, after I'm done with this game, I think I need to do some like toy projects to teach myself more shader stuff. So I'm gonna learn about transforms, cameras, and lighting. Yes. I've done all this one time before, but it's been a long time, so I'll basically be relearning camera projections other than orthographic as I get there, but it actually is kind of interesting. I always liked it. The mathematics behind camera transforms and world transforms and all that was pretty cool. Lighting can get pretty intimidating depending on how deep you want to go down that rabbit hole, but a simple like ambient and specular lighting model usually is pretty quick to get up and running once. Okay. That's a to-do. Is that in my to-do list? Nope. You can put that under tech debt. It's not important, it's not huge, but it's just more of a quality of life thing. We could do it, but I just don't feel like fiddling with command line parameters right now. Okay, so with all that in, VE Tokenizer definition. This all goes away. We don't check valid anymore. Here's fine log. Okay. What we cared about here was looking through our token names. So let's actually go reading that. VB Tokenizer definition. Instead of calling them tokens, token names. I think that will just be clearer for me. So we should have a list of token names. which we can also log when we print things. So log. Token names. Oops. I want this text. There. For token names, dot size. There we go. Const char star. Okay. Token name and underscore token names. You know what? Let's just do this by next. Token names dot size. Let's index. Log modulus D, so we want the index of the token, and then we want the name of the token. Index underscore token names at index dot c. Oh, I don't need dot c string, we're just there. Now we'll see all of that. Comparison of integers. Oh yeah. 32T. I do have standard int, so that should be good. Index was not declared. That's because I deleted index instead of int. Okay. Okay. Tokenizer, token names, there are 4 of them. Line, white space, comment, TokenID. So we can go to our test.v token test.v token. We can have another one that's hash comment. We can have another TokenID which is all lowercase. Because why not? Now when you run, you can see that we have 6 token ID token rules, but we only have 4 token names. That was the whole point of this operation. We need to get a unique index for each token name. So that's done. Copy constructor call. I don't remember. It's in place. Okay, so one thing we can do is allocate the rules ourselves. Which means clear has to be changed. For each thing in rules.size, delete m underscore rules at that index, then m underscore rules dot clear. Then instead of mplace back, we just push back the new VV tokenizer rule. That looks something like this, if I remember right. VV tokenizer rule. Rule ID, token ID, name, actions, regex.
Oh, let's do that again.
Looks good. Oh, but the rule ID and the token ID, we can now get the token ID. Yes, that was the point. Token ID. Okay, now we're causing issues, and that's fine. You know what? VB Tokenizer definition or rule star rule equals m underscore rules at index. Now this
Oh no.
changes to rule.
I thought is he killing it?
Like that. Let's see how we clean up. Boom, everything works. List of tokens. We've got no more copy constructors being called. Thank you. It doesn't mean we have worse spatial locality, but again, this is not a 60 frames per second kind of requirement here. This code can be slow. I don't care as much about the speed of this code that we're writing right now. What I care most about is the speed of the code this outputs. So all the joys, all the trade-offs. Yeah, I'm kind of using graphics as a way to motivate myself to learn more math, especially linear algebra. Yep, that's the way to do it. You have to have, to learn something new, you really need an application that you work through. And yeah, graphics will teach you all the math.
You went that way on.
Yep, you need a project. You need something real and active. I agree. Okay, so that's done. This is perhaps not something strange bug. You have did it last week. So this one's done. This is not done, but that's fine. Debug last week was introduced when we tried to store the tokens in a unique one-to-one index name mapping. The issue was unrelated, but the VB Tokenizer definition of project dot our step file name is not being initialized to null. So when clear was called, it was trying to delete trash memory that hadn't been allocated. A null initialization fixed the bug. Then added in the token name list. So we have that 121 token ID token name mapping. Done and tested. Done, tested. Okay, now I get to move on to fun things. Phew. I've heard lots of compilers for their intermediate representation of code. They will often use S expressions because of its ease of parsing. Have you done that before or considered it? I have not done it before. I've not considered it. Most modern languages go to one of a couple of different forms. That's pretty common. I mean, if you want the Bible on compilers, this is a terrible book. It is very hard to read. It's not written to make understanding happen. But if you do understand it and you read through it enough, they have a whole section on different intermediate representations. Like you have the 3 address codes. That's others. Let's see. I read through that a while ago. Lexical analysis, syntax analysis. Yes, I know those. Intermediate code generation. So 3 address code is very common. So static single assignment, that's the word I was looking for. Static single assignment is like a more restricted version of S expression. So an S expression for those that are not in the list, no. An S expression is parentheses and then a function name and then all the arguments that go with it, and then closing parentheses, which, if you think about it, is not actually far off of the C calling convention, right? Name, parentheses, args, how to think, right? They just move the parentheses outside. So this is called an S expression, and it always returns something, even if it has to be null, which in Lisp is nil. And there are some nice things about this. As pointed out by Dankly Tuned, the S expression is trivial to parse because each argument can either be an atomic value, so 123, or hello world, or it's just another expression, which can be another function and its arguments. So to write a parser, all you ever have to do is say, give me a parentheses, the first thing is a function, everything else inside of it is an argument. And if I hit another parentheses, I parse and evaluate this thing, and then that value goes in this argument place. So trivial to write a parser, because the syntax is so simple. And there's a lot to be said for that. For example, early, what was it, AutoCAD or just CAD? There's a CAD program, I think it was AutoCAD. And in the beginning days, they used Lisp to define your shapes because engineers didn't want to learn a whole programming language, and learning S expressions was so much faster and easier. There's no syntax to learn. So if you think about a static single assignment kind of representation, you're saying literally in your intermediate representation, I have an integer named x and it gets 0, right? So let's turn that into a 3-letter assignment. We're going to make it an integer-sized thing called x, and the operation is, well, it's not interesting. It's just an assignment, right? Y is a 2, so let's write some actual C code here. Int x equals 0, int y equals 2, make it a 1. Then we can write int z equals x plus y times 2. Okay. So what static single assignment is going to say is it's going to say, here's a variable x, we're going to set it to 1. Here's a variable y, we call it, set it to 2. We want to stuff something in z, but we have to compute this first. So it's going to say int intermediate 1 equals y times 2 int intermediate value 2 equals x plus intermediate 1, and then int z equals, well, This would be Z, right? So this is basically what it would do, is it would say everything can either be a single operation, store, or it can be a two argument operator and a store. So an operator that takes two things, or one thing, I guess. One or two operator, a unary or binary operator stored in a thing, and that's all you're allowed. But what you can now do is this interim one, if you see this code anywhere else, you can be like, oh, wait a minute, or at least within your block, you can go grab interim one without recomputing this. Also, we can then prove things about how these numbers relate to each other. So this is a static single assignment. Static single assignment. So if you think about it, this is the S expression. If we just have some examples, C. Static single assignment. So if we were to write an S expression for this, and I'm kind of working my way through the logic as well, is you end up with basically what oh gosh, it's been too long. Set QX1, set Y2, and then I don't know if they would do intermediate values or if they would just literally say Z equal to plus X and times Y2. So if you look at each of these forms in here, this Y times 2, that is its intermediate value. And then this plus X plus the intermediate value is this. Okay? So does that make sense? Like, semantically, each form in an S expression is the same thing as an intermediate value computed in a static single assignment. It's almost like inlining SSA would be performant. You don't want to inline your SSA. The whole point of SSA is every variable is assigned once and only once, period. It makes a lot of the analysis much simpler if you don't have to worry about multiple assignments to the same value. But that's kind of like, that's what Lisp does, right? I mean, at its heart, in its purest functional form, values are not modified, they're only replaced. Yeah. Yeah, so if they're very similar. An S expression and an SSA representation is very similar in terms of that intermediate representation. Cool. Pat just renamed the 71 built-in functions to be actually coherent. If I don't see underscores, I get angry. Oh, function naming. All right. So for me, or function or method function name, I prefer, what's it called? It's not camel case, right? Camel case, snake case, kebab case. Then there's one more. I can't never remember the name of it. Yeah, classic Lisp would be very functional, like you said. Yeah, exactly. Was it Pascal case? Is that what it is? Pascal case? I think that's right. No, I'm backwards. This is Pascal case. This is camel case. There we go. What I tend to prefer is class object struct definitions are Pascal case. Functions and variables are camel case. And I will sometimes mix camel case and snake case. So for example, if I have a measurement, like a real world measurement, like distance to center line in meters, okay? I will mix my camel case and my underscores. That sort of thing. So probably not the most common usage, but let's see here. Think the tune. Foobar versus foobar. I see foobar in JS a lot. Yeah. Find is the function to find the index of the first occurrence of a value in an array. I just changed it to array find. Yeah. Oh, and for built-ins, yeah. Prefixing with underscore to make sure that they look different. Definitely agree. That's a reasonable path to go. Yeah, and find in what? If it's specific to a type, it at least needs a documentation string. Right. Okay. Well, we have wandered round and round. But we have everything we need now. Particular journal. Yes. Okay, so let's get this committed. Git add everything. Commit -m. Oh. While we were in there, we improved the file buffer read to log better information. And in main, it checks if the file buffer is empty before passing on to the project. Just a bit of cleanup there. Couple of minor fixes. Mostly the issue was not null initializing project dot something or other, which I've already got the name of. Also now have list of unique token ID, token name. Okay, now we have a whole bunch of rules with each with their own NFA. Type specific law. Not entirely sure how AI thought that was acceptable. Yep, we gotta hold the AI's hand and walk it slowly and steadily. But then all this AI code that you've just created, you're gonna put it on GitHub, and the next generation of coding is gonna pick this up, and it's gonna learn from your AI generated code, and then it'll learn from the next generation will learn from other AI generated code. And not everybody's going to clean it up as well as you, so it's going to be interesting to see how AI trained by AI data fares. Maybe I should keep it up off GitHub. Yeah, we don't want AI inception. That would be good times. Okay, found bug. What we have now, each rule has its own NFA. Are we on the NFA? Let me look at the Tokenizer rule. We are not compiling an NFA yet. Oh, but that's okay. We didn't want to here. Yes, we want to do that in the VB Tokenizer definition. So here we need the NFA, which we've got. Good. NFA. NFA. parse needs a helper function. It needs to be told how to void parse NFAs. So the tokenizer definition. Let's bring this out separate for now. We can make it private later. Tokenizer definition.cpp. NFA is null to start with. Anything else I need to initialize? No. Then we're going to parse NFAs. This is where things start getting fun. For each rule, we are going to get its pattern and compile it. So we need NFA compiler. Oh, that's not what we would call this, is it? It is pattern to NFA converter. At to NFA. Whose interface I no longer remember. Compile. At to NFA of rule 22, zero, compile, rule ID, rule TokenID, which we are now passing in, and rule point to our pattern. None of which it's name, it's regex. Why do I not have access to the rule in TokenID? Because it wasn't useful until now. We weren't setting them properly. Ah, okay. So I'm gonna add those real quick. M underscore rule ID. Token ID. Okay, good. Now BV tokenizer definition. I guess this is called regex here. We should get an NFA, which we will do nothing with right now. But we will print and just make sure that it's doing what we expect. The point of AI for business is to not clean up the code. They want automatic code. So they can eventually fire all of us programmers. Their dream anyways. Yeah, I have a mini lecture semi-outlined in a text file somewhere to talk about why AI, or at least large language models, will never replace me. or good programmers. And actually, that there's a corollary to that, that increased reliance on AI for programming or art or something else is basically pulling up the ladder for anyone who's in the beginner, intermediate, mediocre category, so that they cannot progress to good quality in whatever their field is. Proper prompt engineering can make decent code, but it takes an experienced programmer to tell the AI what to do and not to do. Yes. Otherwise, you get code that resembles someone that's copy and pasted a few snippets here and there and calls themselves a programmer. Yes. Yes, exactly. It's like one of these Stack Overflow programmers. Yeah, I can do that. Google, copy paste, off we go. Don't have to think. Thinking is the important part, though. Okay, NFA. Remember what options I have available. I can log the table. That's probably the easiest thing. Temp NFA to log table. Log note. Log an empty here. Rule something. Token something. And then I want the pattern. So basically, this. Then a blank line. I don't remember this project. Expose. My tokenizer definition. It does not. And I don't know how I feel about that right now. I'm okay with it. Const tokenizer definition star token definition const. Oh, I've already. Yes. Right after coding. Okay, return the address, underscore tokdef. Easy main. Let's log an empty, and then proj point to token definition point to I forgot what I even called it. Parse NFAs. We're just gonna throw it all away. We just want to make sure it prints out okay. Oh. It's fine for now. So let me go make that change real quick. For now, this doesn't do anything, so we can mark it as const. We will undo that here in a bit. This is just for debugging. Make sure the flow is working. Yeah, full stack web dev. If you're going to replace someone with AI, web dev is probably the most likely place because it's the least interesting in most cases. Critical component in a business, less easily replaced. No, I mean, somebody has to crank out all that HTML and CSS. But it's not the same as like taking a really hard problem and conceptualizing it differently. I think there are people who are web devs that are good programmers, but I think that there's a disproportionate volume of web devs who aren't good. If you're an embedded engineer, you can't lie. Either your hardware works or it doesn't. Either the GPIO pins are getting set or they're not. If you're basically if you're in any other field, it's unforgiving. Web dev, you make a mistake, doesn't seem to have that big of an impact on anything. Like, oh, the page didn't render quite right. The button's over there instead of over here. It's not. I know I did web dev for a while. It was very unfortunate. So, if you're in this chat, it's probably because you're one of the good web devs. I attract only the highest quality viewers. Maybe I should do that lecture one of these days. How LLMs will not replace us, or me. Maybe we should finish that up and do it. Boom. So each rule has a token, a pattern, and an NFA. We did delete it immediately afterwards, but this is the intent. This is not as helpful as we might hope. What we want is one NFA for all of these. So we need a way to combine all these NFAs into a single NFA. And it turns out actually not to be that tricky. So, what I don't remember off the top of my head is, have I commented that code out somewhere? Or is it live somewhere waiting for me to just call it? NFA. Oh dear, I don't think it's in here. Add state, pattern, log tree, log the table, export graph is. We have more code for writing out an NFA than we have anything else. NFA representation itself is actually not very big. And in fact, logging it in the simplest way is not very big. Like this is only what, 10, 12 lines for log tree. Table is the worst, graph is next. Okay. Do I steal the code or do we just work through it? Okay. Let's make a new function. Let's look at what we've got first. Join and delete. Is that correct? Is that how I want to do this? I think that's reasonable. Okay, so what's going to happen is this NFA is going to take control of the states of the other NFA. And by take control, I mean we're stealing them. The other NFA will not have them in the end. Maybe we should call it steal states and delete. Steal states, join and delete. Oh, let's just call it join and delete. It's fine. So what's going to happen is we're going to store our start state. Start A equals our start state. Our start state B is going to be the other start state. We have some easy operations we can just blaze through real quick. One thing we need to do is for each it's just called states size. This one 2. It's index. It actually wants to be a size T, but I don't use that. I use unit 32. Temp state equals other states sub index. Then this states, oh, it's here. Add state. Okay, here's an interesting thing. We don't want it to reflip the output states. Therefore, we're going to lie. Bool was greedy equals this. State point 2 is not greedy equals false. Either way. Then we add state. Temp state. Temp state. State. Then we can restore its greediness. Just so we don't flip those things. Plunder the NFA. Steal if I've already done it. Well, yeah, but the way I did it may not be. I remember being displeased with what I did there. And I think this is going to be much cleaner. But we are definitely plundering. We are stealing all the NFA states without regard to anyone's feelings. So we've literally copied every state and then other states not clear. So they will not have any pointers to what they had a pointer to before. Also, other start state will be null. We're stealing that. Last piece where we set start state. We have no rule ID or token ID. This new state I'm going to create, I think, defaults to -1. If I was smart, I did not. Ooh, terrible on me. Terrible. Yeah, it's an initialization. Okay. Set start state. Oh. Okay. Mostly just need these. So our new start state will be new NFA state. New start equals new NFA state. Which needs an operation. And in this case, it's going to be an what's it called? Alternate. Starting state is start state is start. Okay, the last piece we need is start state point 2, out 1. Everything else I think is just fine. Equals start A. Out 2 is the start B. That's it. I think we're done. Actually, this is much cleaner than what I had before. Let's see here. Anything else I need to clean up when I plunder? Start state states the text buffer. I don't really care about at this point. It can go away with the destructor, so that's fine. See, this is what we wanted to prevent. We don't want this to delete the states unless we actually own it. So when we do that join, we're stealing that data, so I don't have to copy it all. And that leaves this one with the states empty so that it can't delete any of the states that we want to keep around. So that's why we're doing full pillage. Okay. Actually, it's not bad. The most stupid part is this. But at the point that we're joining this, I actually don't care about is greedy at all. Like we can just, we don't have to restore and maintain our greedy state. Everything's been computed. It's only for printing that we have that greedy notion. So this might be good enough right here. Therefore, VB Tokenizer definition. So here, okay, we need to make this not const anymore, which I guess means for now we need to make this not const. While we play with it. We're going to eventually push this down into the automatic processing, but for now I want to run it manually. So this can't be const anymore. Okay. Now what we need is last NFA equals null pointer. Processing changed a little bit. If last NFA equals null, don't do anything. If it is null, then we don't do anything. And last NFA equals temp NFA. Was then we are taking our last NFA, join and delete temp NFA. Oh yeah, last piece, I promise. NFA.cd. Since we have plundered everything, we delete other. NFA equals null, just so we don't accidentally access something later that we already know processing. This actually isn't a thing. Okay. Could make this. You know what? Zero. Cool. File. Now we don't have to check for null. Then we just skip the first one. Rule equals thing, temp NFA. We do not have to check anymore. That actually simplifies down quite a lot. Then NFA log table, and this should be a fairly sizable table in theory. Only I copy paste that correctly. Boom. We now have a table that in theory just about does this. Except it obviously doesn't. So we made a mistake somewhere. And by we, I mean I. Oh, okay. Well, hold on. Start A, point to is start. Oops. Those false. These are no longer starting states. I don't think that fixes anything, but call EV Tokenizer definition. Okay. Hmm. This is so close. What is it doing wrong? Join and delete temp NFA. We get our two start states. We say you're not going to be starting anymore. We take all of the other states, say you are not greedy anymore, so we don't accidentally flip your two outputs. Then we add state temp state. You know what? We don't have to do any of this. We can just push it back. One. Really simplifies things a lot. Other clear delete. Start state equals alternate. We steal the two. Oh. States. That's not it. States dot push back. My start state. My new start state. Okay. We're creating a new state out of thin air and not putting it on this list of states. Back to the stack dump thing. Sheesh. Hey, okay. We're so close. Okay. We check if temp NFA not equal to null. Then we do things. NFA not equal to null. Otherwise, you have to delete our temp NFA. Thank you. I know each individual temp NFA is compiling correctly because we saw that before. Up here. Here's the A through Z. New lines, white spaces. All these look about right. Here's a new line, here's everything that is not a new line. Here is another comment with everything not a new line. A through Z, A through Z. So these are all correct. These are all being done. We're happy with those. Oh, we do have backtrace information. Parse NFAs. Line. Somewhere in here. NFA log table. Okay, okay. Because we aren't preserving the pattern. The text versions of these things. Okay, we're about to do this. NFA table has listing states. As long as it prints it, you can see where we're going here. Pretty sure that's what the problem is. It's 26 states. Okay. So we go back up here. We have 3, 6, 9. 9 plus 4 is 13. 14, 15. 15, 16, 17, 18, 19, 20, 21. 21 states. 21 states. Plus 1 to join. 22, 23, 24, 25, 26 states. 7? One, two, three, 4, 5. 5. Yeah, this one is not even joining alternate. So 5 plus 21 is 26. So that is the correct number of states. We are doing it. We are doing it correctly. We just can't print because these things weren't preserved and carried over correctly. NFA log table 131. Let's take a look at that real quick. Where's the log? Table line 134. But I'm just moving the states over. How can they be? Okay. Does this? Oh gosh. This might be why the old version was more messy. Okay, so when we build an NFA, we hand in a string and we set our pattern. Then all of the inclusion and exclusion sets reference this string without copying anything. So when I blow away the old NFA, that buffer is not preserved. So we do have to add a little bit more to join and delete. To steal text buffer and offset the inclusion sets. We are stealing. Alternatively, we could keep a list of all the buffers that we're stealing. Might be easier. Okay, I think it's time for restroom break. And then we'll get to this. Okay, thought about it, and I think I just want to steal the whole text buffer. So we're gonna make some changes here. Text buffer, buffer. Buffer is not equal to null. Declare it, delete it. I think. Pretty sure the text buffer cleans itself up. And it's destructor. Yeah. It's not necessary. I think we'll do this last after we clean up the states. Set pattern. If buffer is null, buffer equals new text buffer. Copy buffer. Size. Contents. Okay. So that's one change. See how bad that is. Did we break things all over? Oh. Not too bad. Reasonable. Okay. Now in NFA, we're going to have std vector of text buffer star stolen buffers. index 0, index, oh yeah. Unit 32. Plus then m underscore stolen buffers size. What's the index? I think this is going to be easier than what I did last time. What I did last time was I'd take the pattern from NFA1 and the pattern from NFA2, and then I'd allocate as much space as both of those strings, plus 1 for the alternate, 2 for parentheses, and 2 for parentheses. And then I'd copy all of that in to my new pattern. So that I could print the whole pattern out. But that's kind of pointless in this case. It's not really needed. Star buff equals m underscore stolen buffers. The index if buff not equal to null. Buff. We probably need to check that. We can probably just delete. I don't see any case where that isn't true. M underscore stolen buffers dot. Figured. Okay, so we can have and clean them up. Lastly, stolen buffers push back other buffer equals null. So that our other NFA doesn't clean its own buffer up. I also kind of don't want to create a misleading impression that this one has a real text buffer it was built from, because it's not. Therefore, if our buffer is not equal to null, I want to steal it ourselves, actually. Then our buffer is null. Then, when we log, pattern, here we go. Good job, B. Pattern, yes, 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 and pattern, perfect. We only have one place to change it. Nice word, us. Star result equals null pattern. Null pointer. If buffer is not equal to null, then we do everything just like we did before. Otherwise, result equals new char of Sterling of composite NFA plus 1. Stir copy into result string and done. So when we copy, the first thing we do is we say our buffer no longer correctly represents the pattern we're built from, so we're going to make it null. Actually, that's anyway. Then we're going to steal our own buffer. Then every chance we get, we steal someone else's buffer, put it towards the back. If states.size is greater than 0, meaning we have states, we just don't have a pattern. This is the case. Otherwise, it's just empty. The NFA would be empty. All right, see how that looks. Maybe Tokenizer definition. Let's print that just so that we have something before it blows up. Segfault. Segfault. NFAs. Scan pattern. There's no buffer, create a buffer, copy the text. Scan pattern. Why did I need that? Oh. That's awkward. Is that it? Why would the compiler not complain about a pointer to a pointer not being the same thing as a pointer? These are the mysteries. There it is. There is our composite NFA with 26 states. It's got big letters, small letters, new line characters as exclusions and inclusions, and special characters that I don't remember what they are anymore. There you go. Start state is the final alternate. There you go. We've compiled our NFA into a single NFA table. Perfect. That is that task done. Am I logging something I don't need to log? Yeah. PV, Tokenizer definition. Here. If M underscore NFA null, we should delete it. Okay. Now here, all we really want to do is this, M underscore NFA. Fill it into this. Okay, tokenizer definition. Have an NFA, which we can expose. So after we parse, it's a bool, yes. If result parse NFAs. And now this can become private. Now we can see everything it does perfectly. Now, const NFA star NFA const. Right after logging, yes. Object dot NFA to log table. It should have a very similar result. Oh, Proj doesn't have it. VV Proj does expose our token definition. Token def NFA. Log it as a table. Oh. VV Proj. This can now be const again. Right. Oh, my constantness, always fun. How is locking a table not constant? Alright, let's make all the logs const. Const. Graph is const. No. clearing the visited states is exactly why we cannot target. Okay. That only matters in log true. Nothing else. Okay, now. Log table? We don't need that. It will complain. Okay. Build debug BB P pet.bb project. Boom. Okay, so it's all working and it happens automatically, no separate calls. It's just part of tokenizer definition reading it. Boom, part one. Journal. NFAs now parsed per tokenizer rule and joined into a single NFA stored in the tokenizer definition. Automatically during loading the def file. Also, if you work with it, its status, it had everything, it single NFA for whole tokenizer definition. And done. Phew. Okay. Brings us to our to-do list. I do not know why. Well, probably because it's a one-liner, two-liner. I haven't really got a roadmap of things here, so I'm just kind of working from item to item as we get there. So, token definition, build DFA from NFA. That's my next task. So we need a DFA to play with. We've already included it and the NFA to DFA converter. So easy peasy. UP tokenizer definition, that's UP. Underscore DFA, null pointer. Clear. Clear matters. Same treatment. We do need a access to the DFA once it's created. I really have putting 2 of those on the shelf. Yep, I am. Cute. Okay. Wait, parse DFA. We assert that we have rules. We assert that the NFA is not null. We assert the DFA is null to start with. NFA 2, DFA converter, DFA to DFA. And in theory, we wrote this all very cleverly, so it's not too bad. File the NFA. Easy enough. That's basically it. With DFA dot H. Logging is constant. Good. This might be the end of building NFAs and DFAs. We might be able to start outputting text. Oops, full clean. Doesn't matter. Doesn't take that long. Boom. I don't like it. This DFA does not look like this NFA. Oh, well. Part of the problem could be we are not renumbering the states, which makes it very hard to read. That does make it very hard to read. Still doesn't make this look right though. Let's fix up these state IDs so we can at least read them. We're in the stealing portion here. 8. Okay. Oh, magically just like that. Now the states look like they make more sense. This is the start state. It goes to 21 or 22, which was also an alternate, or an inclusion. This alternate goes to 17 or 18, which is an alternate or inclusion. Yeah. And then, magically, if you number them correctly, the DFA prints out fine. So in state 0, we look for white spaces, we look for forward slashes. Okay, let's try straight through here. If we get a white space, we go to state 1, and we can get as many white spaces as we want, and we can approve. If we get a forward slash, we go to state 2, which means we need another forward slash, so we go to state 6. And after a forward slash, we can get a new line or character. That was 6. Oh, anything which is not a new line character. And we can hang out here until we hit one that isn't an accept. We go get a hash, go to 3. We read everything that's not a new line character and accept. We get A through Z, we go to 4. State 4, we keep grabbing up A through Z's until we can't anymore, and then we accept. And little A through Z, same thing, except in state 5. It works! Huzzah! And done. That was an easy task. Good thing we spent all that time building the DFA from the NFA. NFAs now loaded. Tokenizer definition now computes DFA from the composite NFA. There's not really much more to say there. We have it, we're done. I think that's the truth. That's compiling DFA from NFA for maybe Tokenizer definition. And done. Yeah. That's actually really good progress. Not bad. I love it when a plan comes together. Now, we have everything we need to start outputting code. So I guess we should do that. Question. Does the project know if it is valid or not? Anyway, for me to ask. Oh, it returns result. So, yeah. Valid. Okay. Failed to parse VB project file. Proj file name. And this is where it's going to go. Okay. Where to begin? I think we can just about straight. Well, okay, so here's our plan. We're going to output two files. We're going to output a header file with the, I guess, publicly facing interfaces that we want people to use, and then an implementation file which can contain a lot more than what's declared in the header file. The idea is that people will be able to compile a single object file for their whole parser. It'll be a big one. It is not going to be a small file. It will be tens of thousands of file lines or more. All right, so over to the journal. Let's get our next task. Generate some output. Let's start simple. I like it. Output header implementation files with space. Okay, we're into code generation. We got almost 3 hours left. Oh, no. Power's out. All right, I'm going to stop the stream, fix my power. Just a minute.